Okay, we can start.
Okay, I want to switch over to the same topic that we we did up to now, and this is the more the better. Okay, and now I emphasize the question: can more information hurt the informed person? Let me just tell you this: if we're talking about decision science, where I am the only decision maker, then clearly more information can only help me. If not, I can ignore the information. So knowing more can be only good for me, okay? It's not clear if this is the case when we have a strategic conflict, because if you know that I have the information, you may also change your action. And as a result, I change my actions once I know somebody gives me some information about the problem that I face or the conflict that I'm involved with somebody else. So that may cause me to switch, but also you know that I'm going to switch, so you may also switch your strategy, and as a result, both of us switching, and may be worse off. We saw this example at the beginning when we start about what happens if one of the players is getting more payoffs. It's not that far from that. But I mean, the game that I'm going to describe to you that has the information is actually a sequential game. And formally, we're going to analyze when we go to dynamic games. So here, I just want to give you an example. So an example of how extra information influence our decision. So let's take an example of two firms. One is IBM, the famous one. The other one is JBM, okay, some artificial one. And suppose that they compete in the software market. Okay, so what they compete for? They consider to develop a software, but they are not sure should they develop software A or software B. They are not sure which of the two softwares fits better consumers' need. For instance, one of them may be completely irrelevant, and therefore both of them, I mean, if anyone is going to develop that software, it's going to be disaster. They're going to lose money or to make zero money. However, one of them, I'm assuming, is a good one. So it's not clear whether it is A or B, and none of the two firms know about which is the good one. The two softwares are equally likely to fit consumers. So what is the chance that A is the right choice? This is probability half, I'm assuming. And what is the probability that B is the right software? Also is probability half. So that's what they know. IBM and JBM, they know that they should decide whether to develop software A and marketing software A, or do the same thing for B, but they don't know which of the two is the one fits consumers. IBM moves first and decide which software to produce. So they are leaders in the industry, and therefore they decide first which software to produce. The competitor JBM observes the decision of IBM. And by the way, typically, I mean, even if IBM hide it by hiring some employees from IBM, JBM can get some hints about which is the right software. And here we assume that once IBM moves first, JBM will find out which software IBM is going to produce. So they can either mimic them and produce the same software or going opposite. So the competitor JBM observes the decision of IBM, and then after observing the decision, it makes its own decision whether to mimic IBM or to counter IBM's choice. Now I want to give you some data. if JBM chooses to mimic IBM, then I'm assuming that each one of them will earn $2 billion if the software fits consumers and zero otherwise. Okay, so they will compete. None of them has any, I'm assuming, any advantage of the other. Let's say that both of them has the same powerful marketing department, and therefore they can, can be symmetric in the competition in the market, each make $2 billion. If JBM counters IBM, the firm with the appropriate software, the one that fits consumers, will become a monopolist and will earn $5 billion, while the other firm will obtain zero because they will end up with the wrong software. So now let me just say a word about the 5 and the 2. When they compete, each gets 2. When a monopolist, they can make 5 because a monopolist can make at least as much as the 2 firms together by producing the same amount that each one of them, by producing the total quantity that the 2, when they compete, produce, but IBM or JBM, the one that has the right software, can even do better. Maybe by producing less and therefore causing the price to go higher and making more money. So in general, a monopolist, the monopolist obtains more than the total profit of the 2 duopolists. So 5 is more than 2 plus 2. Okay. Assume that when taking decisions, the firm objective is to maximize expected profit. Look, IBM and JBM, they make a lot of decisions in time. Sometimes they make the right one, sometimes the wrong one. But in general, you want them that they expect, on expectation, they should do the best they can. So here I'm assuming, and this is typically, the assumption in games where you have uncertainty, or even in economics with uncertainties, that the players maximize their expected profit, expected utility. So now let's see what is the result of this competition. So if you want to think a second, again, let me repeat, IBM moves first. They decide to produce either software A or B. Then B sees what IBM does, and then JBM decide to do the same or to go opposite to IBM. In a case, both of them produce the same software and it's the wrong one, both of them get 0. If both of them produce the right one, because of competition, each one of them is getting $2 billion. However, if only one is right and the other is wrong, then the one that is right is going to make $5 billion, leaving 0 to the other one, because the other one is left with the bad software, or the unfit software. So this is the game, okay? And then what is the optimal solution? Nash equilibrium. Forget about even Nash, because you can solve it by dominant strategies. Remember, I want to remind you, if you can solve the game via dominant strategies, you don't need Nash equilibrium. Obviously, whatever you get will be Nash equilibrium, because if you use dominant strategies, you don't want to deviate from them. So, so I don't need to use the machinery of Nash equilibrium. It's enough to watch and to see if there is any dominant strategies, okay, in this game. And indeed, IBM cannot do anything. They just guess. With probability half, they choose the right software. And with probability half, they choose the wrong software. Okay. But JBM, let's see, if JBM counter IBM, they will get either 2 if they're lucky, or 0 if they're unlucky, same as IBM. But if they counter IBM, they will get either 0 if they are not, if they are lucky, and 5 if they are lucky, and they will become a monopolist because they go against IBM. So if they are right, IBM is wrong. So actually, they're going to get either 0 or 5, which is better than getting either 0 or 2. Again, if they go mimic, if they mimic, they get 0 if IBM is wrong, okay? And because they mimic, or they get 2 if IBM was right. And if they go opposite, so they are going to get either 0 or 5, okay? So by the way, getting 0 or 5 on expectation is getting 2.5. And if they mimic, they get actually on expectation 0 and 2, the expectation that the average is 1. So if they mimic, they got an average payoff or expected payoff of 1 billion. With probability half, they get 0. With probability half, they get 2. So it is average of 0 and 2, which is 1. If they go opposite, the expected payoff is with probability half, it's 0. Probability half, it's 5. So it's 2.5. So it's clear what JBM should do. JBM should counter IBM, produce the opposite software. And what about IBM? They don't care. They don't know. So they will choose either A or B. Doesn't matter. They will end up with 2.5. Okay? Because knowing that JBM is going to counter them, they know that if they are right, they get 5, because then JBM is wrong. And if they're wrong, they're getting 0, and then JBM gets 5. So on average, they either get 0 or 5, average of 2.5. If they mimic, they get 0 or 2, on average 1. So clearly, JBM is going opposite, and IBM is completely indifferent because they have no idea what is the right one. What each one of them obtains, on average, each one of them obtains $2.5 billion. Okay? Very good. Next, up to now, no information and nothing. Now we are going to give some information to IBM without giving that information to JBM. Let's read it. So first of all, what are the optimal strategies of each firm? Let me read it with you. I said it without it. The solution is JBM can either mimic IBM or counter its choice. If JBM mimics IBM, it will earn at most $2 billion. Actually, its expected profit will be 1. But they make at most 2. If JBM counters IBM choice, it will obtain either 5 billion or 0, equally likely, namely they will get on average 2.5. Therefore, JBM must best, it is a dominant strategy for JBM to choose the opposite software of IBM. IBM must be indifferent between software A and software B, since that it has no information which software is appropriate one. The expected profit of each firm is therefore 2.5 billion. Problem 2. Suppose now that some maven, somebody that knows, he knows which software is the appropriate one. He made some research, he understands. IBM and JBM do not, but he understands that maven. Suppose that he, the maven, reveals this information only to IBM and not to JBM. So he goes and tell IBM, I tell you what is the right software, it is blah, blah, he says. But JBM doesn't know. However, I have to add that JBM knows that now IBM knows which is the appropriate software. So I'm assuming that JBM knows that IBM got the information, but JBM has no idea about what is the information that IBM got. What are now the optimal strategies of the firm? Solution. Notice that now, so what is the solution? Okay, so before reading, I'll read it, but just look at me. Look, now that if I know that IBM knows, for sure IBM is not going to go against what the Maven tells them. Because if they do the opposite to what they know, they will get zero. Let's say the Maven came to IBM and say, this is A. The right software is A. If IBM chooses B, for sure they get zero. So IBM should be completely stupid to go opposite. So the only sensible, that's a dominant strategy for IBM, is to do what the Maven is telling them to do. JBM knows that IBM knows, and therefore they know that IBM will follow the suggestion of the Maven, and therefore JBM should not go opposite, they will get zero. So they are now must mimic IBM. But if they mimic IBM, then each one of them, IBM produces the right one, and JBM mimics them. So as a result of the competition, each one obtains two. And that is interesting because when IBM did not know what is the right software, it got 2.5 on average. Now that they know what is the right software, they get 2. So it looks as if knowing more can hurt you. Let's read the solution. It's exactly what I said, hopefully. Notice that now IBM has strictly dominant strategy, namely to develop the appropriate software. If it does so, it will earn at least 2 billion. Okay, and perhaps 5. Why? Because if the other one, JBM, mimic them, it will be 2. If they don't mimic them, they go opposite, there will be the monopolies because they know what is the right software. So if it does so, it will earn at least 2 billion and perhaps 5. And if it develops the wrong software, it will earn 0 for sure. JBM understands that IBM will choose the appropriate software, and hence it should mimic IBM to obtain the 2 and not 0. If they go opposite, they will get 0. Thus, both firms obtain 2 billion. IBM ends up with lower payoff as a result of extra information it receives. Okay? However, there is something, I want to say, it is not true that IBM got an exclusive information. Let's go to problem 3. Suppose that IBM obtains exclusively the information about the right software. Also suppose that JBM does not know whether or not IBM knows which is the appropriate software. So let's say that JBM has no idea if the Maven told them or not told them, or did not tell them. But IBM got the information, but JBM doesn't know if IBM knows. Can now an exclusive information hurt IBM? If I'm the Maven and tell IBM the information about the right software, but JBM has no idea if I told them or not, can IBM suffer from that? Solution, no. An exclusive information, exclusive in the sense that I give it to one player, but the other player does not know if I gave it to them or not. An exclusive information has always non-negative value in any strategic conflict situation. Why? This is a little bit tricky and it is beyond the capacity of this course. Actually, we can do it easily in the course of games with incomplete information, but it's beyond the capacity of this course. So what do we learn up to now? Actually, we learn how to solve games that can be solved by either finding a dominant strategy, whether weakly or strictly, or by deleting successively dominated strategies. If as a result of that, we get to one outcome, okay, namely one strategy for each player, and therefore one outcome, this is the outcome of the game, and it must be an equilibrium outcome. So if you can reach a unique outcome by successively deleting dominated strategies, weakly or strictly, then what you get, the outcome is an equilibrium outcome. And in that case, I don't need to go to equilibrium and to check for equilibrium is a little bit more difficult than to check sometimes, than to check for the outcome of the game that is obtained by successive elimination of dominated strategies. However, if we cannot, and we left after the successive elimination, we get some strategies for one player and some strategies for the other player, so not unique outcome, then we solve the game by just looking at the Nash equilibrium. The problem with the Nash equilibrium is that it may not be unique. And then the question is how to find or to choose, to select one specific one. This is a very difficult topic. There are a lot of papers and there are a lot of refinements of Nash equilibrium to find out a sensible one. I can give you names like subgame perfect, perfect equilibrium, proper equilibrium, stable equilibrium, sequential equilibrium. There are a lot of different type of equilibrium that actually meant to choose one out of many equilibrium points. Okay, so we study and we looked how to compute the equilibrium and what is an equilibrium. We gave examples. And finally, we got also, I mean, we dealt with the problem, is the more the better, and we show that actually, typically when you give an information to some player, it may hurt this player unless it is very exclusive. That I give that information to the player, but the other player somehow does not know if that player got the information or not. In the next topic, the next section, what we'll do is actually we'll continue with the question, is the more the better, but then we'll use the concept of the Nash equilibrium to analyze traffic equilibrium. Traffic equilibrium has several applications. It can be, I mean, it applies to network design, and the network can be internet network, social network, traffic network, I mean, roads, and we'll analyze, I mean, that topic quite extensively next time. Until then, thank you, and we'll see you soon.